Okay, let's see this one more example for space complexity where you have a recursive call. In the sense, this function which defines a list sum, where you have input as this list as well as number n, like till what index you want to sum the list. So if your n is less than or equal to 0, it will going to return 0. So there is we are not summing any number like that. So like it's assumed index to be from 1 maybe because of that, because if 0th element is something we can, or it might be asking that number of elements in that list, particular list. Okay, so else it is returning list sum. So again same function it is later returning, but with list and number of elements to be n minus 1, and in that it is adding again the plus list 1 of n. So it is again a decrease and conquer kind of strategy in recursion we are going to apply. So we are going to just say that it is summing this, and then we are adding that nth index of that list into the sum. So now defining space complexity for this, we have n number of recursive calls. N recursive calls will be having. So now what is the minimum space required for each recursive call? So either it will go to the base case or in this case. So in each recursive call, we will be calling this function. So this function may take some stack space. So that is a stack space is also needed. Plus every time each recursive call will have one list as well. So each recursive call we will have like this some list sum may be taking some space at the stack, and let's define that space as a k, and that list 1 of particular one index, so let's say what it is taking 1 unit of space. So each recursive call it is taking 1 plus k amount of space, and that will be executed around n times. So your space complexity will be S of p, as we have used this thing. This complexity or space complexity for this particular recursive function will be n into 1 plus k. That k is now your stack memory. Okay. So this is one of the example which I thought I could just take in this video series, where you can just understand how the recursive calls also work for works in a space complexity. So I think you people might be remembering also one of the disadvantage of recursion is it consumes more space. The code is very compact. That code you can write it in very minimum number of lines, but it consumes more amount of space. That is what this says, because this is a stack memory, and it could be like depends on how much space required to store this function, and then plus 1 into how many times that recursive call has been made. So that is why it is consuming more space. Okay, so yeah.